So in these next few videos, we're going to start looking or refocusing back at the TCP control bits or code bits section of the TCP header. We looked extensively already at like the sync bit and the ACK bit and the fin bit. We've looked at those. So now we're going to look at some of these other bits in the middle. We're going to focus in on the reset and the push and the urgent bits. We're going to have different videos for each one of those. So let's start with the TCP reset bit and what that's used for. So this is where you would see it. It's in the code bit section of the TCP header. It's just a single flag, and it shows up like that within a packet capture. So basically this is to be used when there's an unexpected connection problem that happens, and the actual RFC 793, the original RFC 793, gives a lot more details of about 7 or 8 specific instances where the reset functionality should be used. These are probably the 3 most common reasons why you would see the reset flag being sent. An incoming TCP segment from a previously unknown device. So in other words, you know, as a web server, I might have 50 or 60 TCP connections going on right now, and all of a sudden in comes a TCP segment, and I say, wait a second, I don't have any transmission control block for that. I never create a transmission control block. I have no socket information for that incoming segment. I don't know who that is. And so in that particular case, you would respond back with a TCP reset. If you receive a message with an invalid or incorrect sequence number or acknowledgement number field, that could cause a TCP reset as well. Or the receipt of a sync message on a port where there is no process listening for connection. So I gave an example of this yesterday. I said, you know, in your studies for your Cisco certifications, inevitably you're going to come upon BGP. And I said, well, you know, if you're configuring routers for BGP and you've got these 2 routers right here and they can already ping each other, they've already got IP addresses and you can ping each other, and you set up this one right here for BGP, and you say, okay, and by the way, BGP uses TCP, that's why I'm bringing it up. BGP rides on top of TCP. So if this router right here, you configure BGP and you now say, okay, I want you to speak BGP to him. That is your peer right there. Well, the first thing that he would do is he would create a TCP sync message going to port 179. That's the port for BGP. Well, this guy over here, if you haven't configured him for BGP yet, he'll receive the IP packet because the packet is going to his destination address, and he's running TCP, but then he'll say, wait a second, I'm not listening on port 179. That's not a protocol that I'm doing anything with. So in that case, he'll send a reset back. And you might see those in debugs where TCP syncs are going out and resets are going back, and that's because you're trying to talk to somebody on a protocol that he's not even listening to. So that would be another example of where a reset can happen. So a reset essentially kills a connection. If a connection is already up and established and all of a sudden a reset comes in, that's it, game over. It's like it sounds. It says, let's reset this connection. Let's start over again from scratch. You need to do the TCP 3-way handshake with me. We need to reestablish all of our initial parameters. So that's what a reset does. Now what's kind of interesting is knowing this, some people have used this for attacks, for denial of service attacks. For example, let's say that you somehow were able to snoop in on a conversation going back and forth between some employee that you didn't like and the TCP connection that he or she had to a server, like a payroll server or something. Well, if you were kind of sneaky, what you could do is on your laptop, you could start forging packets. Make your packets have the exact same source IP address as that person that you don't like, the same destination address as the server, and in your packets, guess what you would do? You would set the TCP reset bit. So the server would then kill the connection to that employee. The server would be thinking, oh, I need to kill the connection. The employee doesn't want to talk to me anymore. In the meantime, the employee is sitting in his cube saying, what's going on? I can't talk to the server. I'm getting nothing back because the server is getting pounded with reset messages thinking that you're trying to kill it. So that's actually called a TCP reset attack. Some other things I read about this is that actually some routers and firewalls do this intentionally. Some routers and firewalls are set up that they monitor TCP sessions going back and forth, and if a TCP session has been inactive for a while, because we know that the way TCP works is that once it's established, really nothing has to go back and forth for a long time. About every 2 minutes or so, an ACK will go across as like a keep alive, but that's it. So there's some routers and firewalls out there that if they see that, if they see a TCP session that's been up for a while and for several minutes, nothing's gone back and forth but an ACK, the router or firewall will intentionally inject a reset into that connection, intentionally to kill it. So that can happen sometimes. And here's also an interesting fact I read, and I won't name any names here, but back in 2007, there was a certain ISP, a certain internet service provider, and they noticed that some of their customers were using peer-to-peer applications, groupware, to, like, from peer-to-peer sharing music, for example, or sharing videos. And this particular service provider, they didn't like that, because they were losing money. They said, hey, you're supposed to be going to our servers and paying for our stuff. You shouldn't be using groupware to freely share stuff between yourselves. So what the service provider actually did, it was sort of sneaky, was that they had their network set up to look for this kind of stuff, to look for this application, this peer-to-peer application, and then the service provider intentionally injected resets into their network, so that if you as a customer sitting at home tried to use this groupware to this peer-to-peer application, it wouldn't work, because what you didn't know was behind the scenes, the service provider was injecting resets, killing your TCP connection. So that was back in 2007. Well, some people discovered that, and they complained about it, and a year later in 2008, the Federal Communications Corporation, the FCC, basically told this particular ISP, you need to stop that. That is illegal. You are not allowed to do that. And I assume they stopped that. So some interesting uses of the TCP reset field. So now the next 3 slides, I'm just basically going to show you 3 different state diagrams showing you if a TCP host is in a particular state and a reset comes in, how does that affect the state? Does he stay in that state, or does he move to something different? And then that'll wrap up this discussion on TCP resets. So let's say that device A is in the listen state. Okay, so this is like a server that's maybe listening for incoming HTTP. It's listening to port 80. But instead of receiving a sync, which would normally create the transmission control block, all of a sudden it receives a reset. Well, that won't do anything. He'll say, okay, thank you for telling me you wanted to kill a connection with me, but guess what? I didn't have a connection with you anyway, so I'm just going to ignore that message. So there's no state change. Now, let's say that device is in a listen state and it receives a sync. It says, oh, okay, somebody wants to start doing telnet with me or HTTP or something like that. So now it's going to go into the receive sync. So it's going to go into the sync received state. So normally, at this point, what would you expect device A to do? Well, you would expect that he would create his own sync. He would acknowledge the sync he just got and then send that back as a sync ACK. But what if before he has a chance to do that, a reset comes in? So now he's in the sync receive state and he just received a reset. Now he goes back to listen. And then the last state, any state other than listen or sync receive. So let's say you're in the established state, for example. You've got a valid connection with some TCP host, and all of a sudden that device sends you a reset message. Then that immediately closes your connection. It kills the connection. So that's the effect of the TCP reset and how it works on connections. Now there's a question in the live audience. Does a TCP reset get an acknowledgement? Let's see. I'm actually going to replicate this here. So here's what you can do as well if you want to see this in action. So what I'm going to do, and for those of you in the live audience, for just like a minute or two here, you're not going to be able to contact me, because what I'm going to do is I'm going to open up a web page to something, and then I'm going to shut off my wireless NIC. I'm just going to flip the switch here. So my laptop's not even going to have a chance to fin the connection. So the server, the web server out there, and I'll just pick something like CNN or something like that, it's not going to know that I'm gone. It's still going to be in the established state. Then what I'm going to do is I'm going to turn my NIC card back on. Now that server most likely will send me something. It'll send me some JPEG file or some JavaScript or something. Like if it's a website like Google, it's got like little things dancing around on it. It's sending you stuff, right? All of a sudden my laptop now is going to get an incoming TCP message, and it's going to say, who are you? Because remember, I shut off my NIC card, so that killed all my TCP connections. When my NIC card is turned back on again, it doesn't know that it's supposed to talk to anybody. All of a sudden, an incoming TCP message comes in. My NIC card will send a reset. And let's see, when I send that reset, is that server going to send me an ACK back, or what's going to happen? So let's find out here. So for those of you guys on the live stream, because I'm going to be shutting off my NIC, I will lose connectivity with you for just a moment. Okay, so let's go to, I'll go to WRAL.com. That's our local news here in Raleigh, and typically they've got JavaScript and all sorts of junk that they're downloading. Yep, I see it there. Okay, so now let's go ahead and bring up Wireshark. And actually what I'll do is capture interfaces. Let's do my wireless network connection. Let's start this up. Okay, let's clear my filter. Let's bring up WRAL.com. Okay, so I think that all the stuff in purple is probably that website. So now let's do IP.address equals 216.58.217.130, and then we'll say and TCP. Okay, so this is only going to watch transactions between me and that particular website. Okay, so here's what I'm going to do. So right now I've got the website going, so let me reinitialize my capture. All right. Let's just refresh this website to make sure I've got the right one. Yep, that is it. Okay, and here we go. NIC card was just turned off. Okay, and now the NIC card is going to be turned on again. It's going to take a moment for me to associate to the SSID and all that. Okay, so fin, ACK, fin. Okay, so now what we're going to do, at this point I should have sent a reset. So now what we can do is we can go in here, and I'm going to do, I'm going to add to this filter that I only want to look for TCP resets. Okay, so let me put this in here. And I don't want push. I want reset. Let's clear this for a second here. TCP. I want reset. I want to do a filter on that. I want to change that value to 1. Okay. Actually, I think this worked just fine when I went to Google before. Start my capture. Turn off the NIC card. Turn on the NIC card. And we should see here, last time I did this, it created a reset. There we go. Let's just give it a second here to even out. Okay, I think that's it. So now let's go ahead and see, where did the reset first happen? First happened in packet 224. So now let's clear out my filters. Okay, so right here in 220, 199, when did I last get something from 199? Actually, I'm sending resets to a whole bunch of stuff. Let's just figure out which one of these is google.com. And let's look up google.com. So it's probably something beginning with 173.227. So that would be this one right here. Okay, so 173.227. Here's where I'm sending a reset. Did he talk to me before I sent that reset? I'm looking for something with a source address of 173. Where are you? Must be way up here. Well, let's go back to the reset. Maybe the reset will actually indicate why I sent the reset. So right here, here's the reset to Google. And if we go into the, we don't really care about the IP header. If we go into the TCP header, I'm doing HTTPS 443, sequence number, acknowledgement number. So I guess the way we could track this down is this is a reset to this acknowledgement right here. So we need to find the previous packet that had this as a sequence number. So let's do this. First of all, let's write this down. Well, we don't really care about that. What we care about is when the reset went out, did I get an acknowledgement back from the person I sent the reset to? So here I'm sending a reset to Google, 173.227. And when's the next time we see something coming from Google, 173.227? Right here. Okay, so this reset had a sequence number of 7493. Here's Google. Nope, it's not acknowledging 7493. Are they the same thing? 247.59, yeah, so here's me sending a reset on packet 230. That's to Google, and then here I send 3 more resets. I believe those were all google.com addresses. Let's just verify that. 173, so they're all 227, 247 in the third octet. So yeah, 173, 227, 247, that all relates to google.com. So apparently I'm trying to reset here 4 different connections, which is kind of weird because I did not have 4 tabs open to Google on my browser. 247.59, 247.29, 54, and 24. Those are all 4 separate connections to Google. And then here is 59 sending a message back to me. So what's he doing? He's sending an acknowledgement to sequence 5483, but when I sent him this reset, it was 5484. I sent him 5484. He is ACKing 5483. So he's ACKing 1 byte less than this reset. Now we learned about in the sequence number section that when something's actually carrying data, this sequence number actually represents the last byte from the previous segment. And then all the bytes in this particular segment continue to increment. Now, do we actually have any data in this? No. So this is just a TCP header. So this number right here, 5484, is pointing us back to the very last byte of the last segment that we knew about. If we tracked back up, we would probably see that. And then 59 here, so he's sending us an ACK, and then what's the next time we see something from 59? So he's continuing to acknowledge stuff. Notice the size. These are just ACKs. The size of 54, there's no data here. At the moment, Google is not sending me anything but TCP ACKs. So here's 59. Oh, when's the next one we see something from 59? So he acknowledges something. And then once again I say, hey buddy, reset. Didn't you get my first one? I'm trying to kill this connection. Why do you keep ACKing me? So I'm looking at 247.59 here. And here's 247.59 once again, sending me an ACK with no data in it, size of 54. And just scrolling down, when's the next time I see something going to .59? Well, let's just focus on that IP address. Right here. We'll just create a filter of that. Okay, so these are the only 4 things that we caught in that conversation. I sent the reset. Let's see if we can make some of these numbers a little bit easier to see. So here's my reset with my sequence number, and I was ACKing something he previously sent. Okay, and then here, oh no, this is from Google to me. Okay, so this is a message that Google sent. No, 10.7.1. Okay, so this is me, 10.7, that's me going to Google destination, sending a reset. Here's Google responding back to me, ACK. And he is, it's close, he's not quite acknowledging what might be happening here, and we'd have to research this. I know that we talked about this thing called the phantom byte. And remember how we said that when an empty TCP segment goes out with either the sync or the fin bit set, that it's sort of assumed there's this invisible byte of data after it. And so the sequence number sort of references that. That might be the same with reset here, because notice this sequence right here, there's no data. It's just a TCP header with no data following it. And yet the ACK, actually the ACK is doing just the opposite. It's referencing 5483. Normally we'd expect it to be 5485. So not sure what's going on here, but these two match. So when I sent the reset, my acknowledgement was acknowledging his next sequence number, so that matches. So that matches the conversation. 2913, that's what I'm ACKing from him. That's why I say that's what I expect next. And sure enough, this is the next packet that Google sends to me. Okay, and then Google says, okay, I'm ACKing 5483, so that's what I expect next, but I don't give him 5483. Instead, I give him some totally different number of 2283. So it's supposed to just kill the connection. According to the RFCs and according to the state diagrams, there should not be any acknowledgments of a reset. It should just take the established state and immediately move it into the closed state. So we'll have to research this a little bit further. Maybe they modified some RFCs after the original one to specifically deal with resets.